This video is on Unit 13, Lessons 8 and 9, which is all on regression and finding the correlation coefficient. So this first question deals with finding the line of best fit by hand and using the calculator. Honestly, you can probably always use the calculator, but it's good practice to do it by hand as well. So in this first question, we are comparing age versus weight. And they gave us the scatter plot. They didn't even ask us to come up with the scatter plot. They gave it to us, and they asked us in part A to use a ruler. So you guys would actually break out your ruler and try to draw your line of best fit as best you can, so that you can use your line of best fit to answer part B. Now, I used the Smartboard tools to just draw in my line, so you would use your ruler. And for part B, you have to pick any 2 points that are on your line. It doesn't necessarily, you don't want to just pick any 2 data points because not all of the data points are going to be on your line of best fit. So you want to try to pick one that is easy to see. So I might pick that one there, which would be 1324. So I'm going to use the point 13, 24. That seemed to be on my line of best fit. And then can we find another one? Maybe this one here. So this is 210. So I'm going to use those 2 points. So this is a really good review from Algebra 1 on how to come up with the equation of a line given 2 points. The first thing you need to find is your slope. Your slope, remember, is y2 minus y1 over x2 minus x1. So you got to subtract your y's, subtract your x's. So 24 minus 10 over 13 minus 2. 24 minus 10 is 14 over 13 minus 2 is 11. It does say to round your coefficients to the nearest tenth. So 14 divided by 11 is 1.3 rounded. So that's my slope. So in my equation of my line, I know it's going to start off as y equals 1.3x. And then it's definitely going to be a positive y-intercept, so I can put a plus sign. And then to find the y-intercept, you simply pick one of your points, plug those numbers in for x and y, and solve for the missing y-intercept, which we call b. If you forgot the equation of a line, the general form, it looks like y equals mx plus b. So I'm going to use 2 and 10 to plug in for x and y. So that would be 10 equals 1.3 times 2 plus b. I don't know what b is. So 1.3 times 2 is 2.6. And then if we get b alone, if we subtract the 2.6 over, that's 7.4. So now I know that my y-intercept should be about 7.4. So that is the equation of what I thought the line of best fit where it would go. Now, the line of best fit the calculator comes up with might not be that exact equation because maybe I didn't draw mine the best fit possible. So we are now going to practice doing this on the calculator. So I already have mine typed in, but you're going to go to a new list, data list, which remember on the home screen is the middle button, the green one. You are going to label age versus weight and type in the data. Then we want to graph it. So if we go to menu, or no, we're going to go home, sorry, right, home, and go to the pink one. And it should pop up some dots for you. The problem is you need to tell it which data do you want on the x-axis, which do you want on the y. So you just click. And then we wanted age on the bottom, so I'm going to choose my age. And then on the side, we wanted weight. I called my second column weight. And now you should get a scatter plot very similar to the one they already drew for you. So now we want to find the line of best fit, which is the regression line. So that's where you're going to go to menu, and you might want to write these numbers down underneath letter C. Menu 4, analyze. 6 is regression, and then you have to tell it what type of graph these dots most closely would form. It's linear. It looks like it's straight line that they would form. So you want to pick linear. There are 2 linears. We use the mx plus b, and there it is. It popped it up for us. And look at that. It actually is pretty close to what I thought the line of best fit was. not quite exact. It does say, oh, it doesn't say what to round to, so we'll do nearest tenth like we did in B. So according to the calculator, it was 1.2, I believe. Let's bring that back. 1.2x plus 7.8. So pretty close, not exact, but it's because my line actually wasn't the best one. All right, now we want to do the correlation coefficient. Remember, the correlation coefficient tells you how close your data points are to actually forming a perfectly straight line. Or if it's not a linear, it could be exponential, how close it is to forming a perfect exponential graph. So you're going to go back to the home screen. You're going to go to a calculator screen, which is over here on the left. And you are going to hit Menu, Statistics, which is 6, 1, and then we want number 3. You'll see Linear Regression. So Menu 613. We have to tell it which lists to use. So we had age on the bottom, we had on the X, we had weight on the side, which is Y, and then just hit OK. R is your correlation coefficient. That's 0.995. That is so close to 1, which it should be, because if you look at my points, it is so close to forming a straight line. So my correlation coefficient is, it said nearest thousandths, so that was 0.995. I don't think the number after 5 would push it up. Nope, it's a 2. So 0.995. How can you interpret this? It means there is a strong correlation, a very strong, because it is so close to 1. A very strong correlation between age and weight. So that is it for that example. You may have wanted to write down the button numbers that you hit to get everything we did if you forgot that from Algebra 1. The last quick example is multiple choice. It just says which of the following scatter plots would best fit with an exponential. Because remember, there's different types of graphs we could get when we're doing data or scatter plots. The first one was linear. Exponentials, remember, they look closest to number 3. So that is it for this lesson.